started back with Citus 11.0, if I remember correctly. And the idea is to talk about everything that's new in the latest release and give you a couple of live demos as well. Obviously, we know that not everybody's joining us live. Many people will watch the recording online on YouTube later. But whatever way you're consuming this, welcome.
Yeah, welcome. Very excited.
So if we pop up my screen, we can take a look at the blog post that was published by Marco Slot just over a week ago now. And it is a good way to get an overview, for those of you who want to dive in deeper after today's release party. And it walks through a whole bunch of the features that are new in this release, several of which are going to be demoed today. So we're going to do a demo today of tenant monitoring with the new Citus.tenants, right?
Yeah. Ozone is going to talk about that.
Okay. And then we also are going to have a demo today of merge support. Now, Citus supported Postgres 15 from within a week after Postgres 15 was released last fall. I think that was the October timeframe. But merge support is kind of one of the features that we didn't have support for in the very beginning. And then we rolled out partial support in Citus 11.2. And in this release, it's all about co-located distributed tables. And Tasia is going to cover that one, right?
Yeah. Tasia spent the last few months lots of time on merge. So he's our merge expert.
Okay. And then we're going to also have a demo from Rajesh about logical decoding or change data capture, CDC as it's called, and how it works with Citus tables too. But I wanted to make sure to show you this blog post so that, if you want to know more about how shard rebalancing was improved, there's a whole section on parallel shard rebalancing in here. And similarly, I think if I scroll back up to the top, there's a feature on metadata synchronization, which is for people who have really large numbers of tables in their Citus database. So, and if you want to dive deeper, Yelta, I know that we have a release notes page as well.
It's our updates page or release notes. It has all the. It's like the blog post is a bit more like these are the features that we have, and the updates release notes page is a bit more like how do you actually use them, like some examples. So how can you set up exactly like some Kafka client with or something like that, and. So yeah, if you want to read up on what you will hear today from the three people that will talk about some of these features, and you want to do it yourself, this is the page you should go to.
Now, with regards to parallel shard rebalancing, I know that's a feature that you've worked on a lot in the past.
Yeah. I've spent a lot of my time at Citus working on shard rebalancing, and this is also. It's very exciting. Next release. It's going to be it's sort of a small build up a bit to the next release. That's right now. It's not super useful yet, but in the next release, it automatically will be super helpful.
Okay, awesome. And I know in recent releases we rolled out improved features for monitoring the progress of shard rebalancing. Obviously, we open source shard rebalancing a number of years ago now. So yeah, it keeps getting better with each release. So I just wanted people to know the updates page is here. You get to there through the top nav, and you can always pop to the latest version. You can also go back in time and see what was new in 11.2 or 11.1, etc. And then obviously the GitHub repo is where you can keep track of everything that's happening with the release, even before the release comes out. So I think that's it for our overview. Yelta, is there anything else you want to shine a light on before we bring, I believe Ozan is first to give the first demo today?
No, I just want to see the demos, honestly.
All right. Well, me too. So let's welcome Halil Ozan Akgül. Did I say your name?
Yes, you did.
Awesome. Welcome. So tell us, what are you going to demo for us?
I'm going to talk about the new tenant monitoring feature of Citus 11.3 that you can use to track the statistics of your tenants in your multi-tenant applications.
All right.
But you might be asking, what is a multi-tenant application?
You read my mind.
Let's start with that. So it's an application type where your servers and your database serve for all of your clusters, all of your customers at the same time. So instead of like having a separate database for each of your customers, you put all of their data in the same Citus cluster, for example, or like in the same Postgres tables. And it is very important to know what's going on in your database to be able to optimize it. And you can, like, for example, always check out how much of your disk is used, or like check out the Postgres table statistics. But up until now, we didn't have an easy way to monitor like each of the tenants. So in this release, we added that. Yeah.
Okay.
So let me dive right into the demo to show that.
Sounds good.
So yeah, so I created some tables here. Let's say I have companies as my customers, and like I create some tables for them and distributed those using the IDs of the companies. So here, each of the company would be a tenant for me. And I also created some queries. Let me show them too. Okay, so here I have some queries that like insert, like that does insert, selects, updates for like some of the tenants, some of those companies. I will go ahead and connect back to my cluster and run some queries. So now I can look at the Citus.tenants view to see some statistics about the queries I just ran. So here I wrote a query to like make it look nice. Here you can see like which tenant run how many queries. Here read count means that means the select queries, and query count means select, insert, update, and delete queries. So this is just some nice query, but we have many more columns in the Citus.tenants view. Let me show all of them.
Okay, so Citus.tenants, that's the new feature,
yes.
Correct? Okay.
Yes, so this view is a new feature.
All right.
So here you can see the read count and query count columns I just shown. I will come to what periods are in a minute. And we also have a CPU usage column that is for that shows the total CPU usage for your tenants in seconds. And we also have a column tenant attribute. So this would be the company ID here. And we have a collocation ID of the tenant, of the table that your tenant is in. You can find this in the Citus tables view. And also, finally, we have a node ID column that is the node that your tenant like resides in. You can find this one in pgdist node. So let's explain the periods. So instead of giving you all the counts from like since the beginning of time, we decided to divide them into some like time buckets. So we call them periods. And like we count your statistics within those periods. By default, a period is 1 minute, but you can change it. So let me show how that would work. I'm going to open a new tab here and connect to the same database. And 1 second. Okay, so I filtered only for one tenant, and I'm going to put it in a watch. so we can see the updated query every 2 seconds. And I'm going to run the same queries again. So in this period column, you can see the current period, current minute we are in right now. So every time I run new queries, the values for this period columns will increase. So this is good for when you are when you log into database and want to see the real action, like what's happening right now in real time. This period columns are good for that. But if you want to create, for example, some charts and compare how the statistics change over time, this value will not be good because it changes over time. So for that, we have last period columns. Oh, minute just ended, so let me stop this. So when a period ends, we save this period column to the last period column, and like new period start. So the values for last period will not change. So you can use it to compare with older periods, basically. So this period still going on. It can change, and it is good for seeing real action. Last period just ended. Its values will not change, and it is good for creating charts or comparing with other periods. So if we just continue, if I run some more queries, they will again go to this period, and last period will not change until in 10 seconds it ends. So yes, if you want to create the charts I've been mentioning, it would be good to schedule a job that will dump the last period columns somewhere, and then you can use them to create those charts. This also works for other columns too. Let me show them too. So if I run queries, in the other columns, these period columns also will increase, and last period does not change. And one more thing, I also want to talk about how many tenants we keep in the monitor. So we don't want to keep all the tenants you have in your cluster, because there might be thousands, millions of them. So we are just interested in the most active ones to help you optimize those. So let me show in a different query. Okay. Sorry, not this one. Okay, so here I'm showing more tenants now. So we have 3 tenants right now out of the queries I ran. So those are 1, 2, 3. And let me simulate a larger app. But I ran many more queries, and there are new tenants there. We show the top 5 right now, but by default, on the monitor, we show 100, but I set it to 5 for the demo. So every time I run new queries, the numbers increase. And so you remember, we also had 2 and 3. Now they're gone because they were not active enough. So let's say we add a new tenant that is much more active than these. Okay, it is a tenant with ID 12. So the period passed, and the other ones also. So let's run some more queries. Okay, now we have tenant 12 that is much more active than the other ones. As you can see, tenant number 1 is also gone. So we had it somewhere here, but after we added 12, we had to drop it to open space for the more active tenants. And that is it for today's demo. If you want to see more examples and dive deeper in the other parameters, you can check out my blog post on citus.tenants on the citusdata.com. And thanks for listening.
It's the most recent blog post, I think. So
yes, it's
at the top of the
top.
Unless you watch this in 3 months' time, and then it won't be at the top anymore. But you'll find it.
The next time you should just watch the release party a bit earlier.
Yeah.
So is this new feature all about solving the noisy neighbor problem? I sometimes hear the team talk about that term?
Yeah, I guess you could say that it is to find the most active tenants, and then you have to decide what to do with them. You might just like isolate it into a new node, or I don't know. We have tools for that.
Got it. And is there? Oh, Yalta, you go.
Is there any is there any improvements you plan on doing to the in the next releases, like new features, something like that?
So we have some features coming up. I don't want to spoil them, but we are planning to integrate it into Citus stat tenants. But I think one important thing is we are right now working on the performance. This feature has some performance effects, obviously. So we put it behind a enable flag. So you have to turn Citus stat tenants track to all to be able to access that. We also have that in the blog post.
Okay, so it's off by default, and you choose to turn it on. And obviously, not all of our users are multi-tenant SaaS developers, and so not everybody necessarily needs this feature either. Correct?
Mm-hmm.
Cool. All right. Thank you, Ozan, for joining us. This is great.
You're welcome.
All right. So next up, I think we're going to welcome Teja Muparti.
Hi, Claire. Hi, Delta. How are you guys?
Good. How are you?
Good. Thank you.
So you're here to talk about merge support?
Yes, please. So I have some slides. Probably I'll start with the slides and then we'll go to the demo.
Okay. Take us away.
Cool. So merge is a new SQL command in Postgres 15. How do I go to the next slide? Next slide, please. Yeah. As Claire already mentioned, we released the PG15 right away when it went GA, but we couldn't support merge because merge has to be distributed and it's a bit complex than a simple SQL. So we started supporting in phases. We supported in the basic local tables in 11.2, and in 11.3 we are supporting the distributed tables. Just to recap what a merge is, basically it gives the power of insert, update, delete with a bunch of logic all in one single SQL. In the absence of it earlier, I think people used to do like upsert or write a bunch of PL/SQL SQL constructs, and it's a bit messy and more complex. But this is pretty ANSI standard. It's nothing new, but PG support started supporting from 15 onwards. As you can see, it primarily consists of two tables. One is a source. I don't say two tables. Let me call it like two important things. One is a target table. That's where all the modifications are done. The source is where you get all the merge into the target based on some conditions. As you can see in the next slide, I'll show a quick example how the syntax looks like. Here you can see we have a target table and a source table, and they both are joined in a certain joint condition. There are the bunch of conditions that needs to be matched, and then based on them we'll execute either insert, update, or delete. There's no limit on the number of conditions. They go in an order, and the first one that get executed we'll stop there, and that's the update or insert or delete that happens. And next slide, please. So let's consider a scenario where you have one coordinator and four worker nodes. Here you can see when a user starts a merge command on the Citus planner internally splits into 4 merge commands, one for each shard, and the merge actually executes individually on each node. For them to really execute individually on each node, especially the join condition for the source and target to be meaningful and unambiguous, we have to have them co-located. If they are not co-located, it's hard to tell whether it's matched or not, because it could have matched on the node, on that node, or if let's say if it's not matched, that row could have been on a different node. So to really unambiguously decide whether it's not an unmatched, not matched condition, the both source and target has to be co-located. Next slide, please. Okay, so let's quickly show I'll quickly try to show the demo. Okay, so we are going to create a source and a target table. As I said, one caveat is that the source can be a query also, like, it could be like a view or anything, but for simplicity, I'm just keeping it as both source and target as are tables, right? We'll add some data to that, and we're going to convert both the source and the target into distributed tables. If you can see here, I'm going to highlight that. I'm going to co-locate the source table with the target table. We just created them. We're going to create start the merge on 11.1 and see on the bottom of the screen. If you see, it clearly says that, hey, it's not supported yet. That's 11.1. As I said earlier, we started supporting from 11.2 onwards in phases. So let's try jump directly to the 11.3 and see how it works. Here, I just want to quickly go through what we are trying to do here in the merge statement, right? When, let's say, in the source and the target, when it's matched and the target ID is 200, then we are saying, hey, okay, delete that row. If it's matched, update, basically incrementing a counter here. That's, you can see here, val +1. If it's not a match, take that row from the source and insert into the target. That's what we are showing it here.
And if it's matched, it means it's not in the source table, or it's not in the target table.
When it's not matched, it means it's not there in the target table.
Okay.
So source is where everything flows in, and if it's matched, it means our target already has it. So either you update it or delete it. You can do whatever you want to, but not matched condition is applicable only for insert, because okay, hey, target doesn't have it, so okay, take it from the source and put it here.
Okay.
As you can see here, for the 300, right? It's not matched. When 300 is not there, it's not there in that original data. So it came from the source. Whereas this one, it matched. So we updated it. As you can see, it came from updated from the source. And if you recollect, there's a 200 we mentioned here, right? It's gone. It's gone from the delete because it matched, and this predicate also matched. The merge deleted it. We're trying the same thing with large number of rows to see, not just 3 or 4 rows. Here, what we are basically doing is that if it doesn't match, we're inserting another 250 values we'll get. If it matches, we're going to increment that counter. So it will be like 250 plus another 250 values. The sum should be around 500. That's what we are seeing here. And just repeat the same experiment with the Citus local tables, basically. As you can see, both are Citus local tables. The merge exactly works the same as Citus distributed tables.
Now, for people who aren't familiar with the term Citus local table, is that just a regular Postgres table in a Citus cluster that's not distributed? Is that what you mean?
Yes, but it's visible to the Citus in terms of metadata. You can combine. I mean, you can in our practical purpose, you can call it as a Citus table because you can see it from other nodes also, not just where you have created. For a Postgres table, it's visible only on that node, right? I mean, it's not distributed in nature. If here for a Citus local table, even though it's there on that a node, it's visible across because of the metadata synchronization.
Okay.
I just want to show you, I think in the earlier slide, if you recollect, I showed you how internally it works. So I'll turn on some flags. So don't be, surprised when you see a bunch of output. That's because I've turned on this, this flag, not this one. I jumped a little bit. This flag, okay? The one I'm highlighted here, that kind of shows how the internal nuances are working. So it might show some extra output and all, not just simple merge, how many merge it has done. So here I'm showing a single shard merge. Why am I saying single shard merge is that here saying I'm the predicate. I'm giving a saying that, okay, only if the target ID is 125, do certain things, right? So I would expect it should go onto a single shard and do the merge on it. But you can see it indeed went onto all the shards. I mean, the merge happened to all the shards. I intentionally put that one. The reason is that even though you said, okay, target ID is got 125, only do merge there. Remember, the merge has this special thing called not matched clause, and we are whenever it doesn't match, we still have to insert it. So even though the actual update and deletes can happen only at the single shard, but you still have to do the not matched class, and that's why you end up going to all the shards.
Okay.
But let's see the same experiment from the bottom. I'll remove the not matched class and see how it behaves internally.
And you're going to keep logging on again. Yes.
Yes. I'll continue the I know what you're saying. So the commands, yes, thanks. So if you see here, there's a not matched class, but I simply said, hey, do nothing. You don't have to do anything. The Citus detects that, and you can see it did merge only on one shard, the shard where you have this 125 ID. Okay.
So now
the
it can
same-
filter out. Now it can filter out all kinds of things.
Yeah, because I don't need to do evaluate the not matched class. I need to only match class, and I know where that shard ID is, and that shard is here where 125 column is, and then I'll go and just do it right there locally on that node. Similarly, I'm just removed that the extra predicate which I had, so that again it'll. Okay, let me highlight this again. So it'll show a bunch of again all the things. So that's the same thing. Now it's showing for all the. Now we removed that predicate. It's across the board now. There are some combinations we don't support. So we throw some kind of clean mirror message. I just want to show the limitations. The reference tables are not supported yet. So if you try Teresa, we are still on the demo. Just can you switch to the demo? Okay. Here you can see I'm highlighting the bottom of the screen. If you try with a reference table, it says, hey, merge command is not supported on reference tables yet. Okay. Same the case with the non-collocated tables here. Let me highlight this here. It says, here we create both source and target table are distributed, but they're not collocated. Okay. Then it will show some graceful error message saying, hey, they must be collocated. Another case is that, we cannot have, like, for now, mix and match of, different type of tables, distributed and local tables. Here also, again, we tried mix and match of a Citus local table and distributed table between source and the target. It will say it will not. Yeah, we can go to the slide, please. I'll just show yeah. So this might help a little bit right now. The top two, we just demoed it. The next three, that's in progress, which will come in the next release, whenever that is. So the last two are right now, we consider them as not like, great use cases. But above that, everything else, it kind of pretty much covers the spectrum of all the use cases. That's what we feel. But if you have somebody has some real use cases or great use cases for the bottom row, please give us a feedback anywhere on the Slack or somewhere. We'll try to take a look at it.
Yeah, and just to shine a light on what you just said, we have a Citus public Slack that lots of open source users and even some Azure customers are on, and it's a great place to ask questions that might be answered by some of you or might even be answered by people in the community. So that's a great way to reach us. Cool.
Yeah.
All right. Questions.
Really cool talk. Really cool demo. I didn't look much into merge before, honestly. It was like, this new Postgres 15 feature that, like, I don't know what I need it for. So
Yeah, it's very powerful,
it's
SQL.
it's like a really powerful version of like on conflict
Insert on conflict.
insert on conflict.
You're right. Yeah. Sometimes people call it upset, but yeah, you're absolutely right. That's insert on conflict. It's much more elevated than insert on conflict, and it's a long
Cool.
pending. Most of the commercial databases have it for a while, including our Microsoft SQL Server. But I think now that uh, Postgres joined the club, even Citus joined the club now.
Amazing. So you said we could join collocated tables, or we could merge two collocated tables. Can we also merge them on like a non-distribution column?
Not right now. The problem with when you don't join in a non-distribution column, right? So it's kind of tied to the co-location concept what we talked about earlier. Um, if you join in on a non-distribution column, we don't know whether they can. It's that particular row of the source is on a different node, unless you bring that, unless you kind of, what do you call it, redistribute them based on the exact same distribution column. So it's kind of tied to that co-located column. That's why he said co-located and joined on their co-located column, maybe, if you can say it that way.
Okay, yeah, that makes total sense.
Awesome. Well, thank you so much for joining us, Teja. I don't think I had more questions. Did you, Yelta?
No, I think I mean was a great demo. I was very clear. Thank you.
We actually had a longer list of questions, but you answered them during your demo, so you nailed them before we even got there, which is great.
Okay, thank you.
Thank you, Teja. And there's more information about merge support in the updates page for 11.3 as well. So that's the place to go.
Well, all these topics, there's lots of extra information if you want to read up. Hey, Rajesh.
Hi, Rajesh.
Hi, LT. Hi, Claire. How are you?
Good. Welcome.
Thank you.
So you are going to be talking about logical decoding, change data capture. What is logical decoding?
Yeah, this is a feature in which Postgres client can look at the changes in a particular table or a particular schema. Instead of getting all the changes in a Postgres server, you can look at one particular table and replicate it. So this CDC feature, that is change data capture, is built on top of logical replication.
Okay. And you're going to do a cool demo for it.
Right. Yeah.
All right.
So sure. So let's get into the demo. Okay. Just want to give an overview of what we are going to see in the demo. This change data capture is a feature by which any change that is happening in a distributed table, it could be an insert, or it could be an update or a delete. So if there is a non-database client, it could be another application, it could be a microservice that is listening on this change. So this feature enables those downstream components to look for any particular events happening in the database and take appropriate action. Right. So a common use case for this is Kafka clients. So in this we are showing a Citus cluster that has a coordinator node and two worker nodes, and we have one distributed table, IoT sensor data that is captured in a sensors table, and this is sharded across two worker nodes, and we see that there are multiple shards are there. Now, application that is a Kafka client is listening to this change, and any event that is happening in the sensors table should be replicated, should be available for the this application. So there are multiple use cases. It could be for auditing, or it could be to detect some kind of anomaly condition that has happened, or it could be a communication between one microservice and another microservice, and based on the events that is happening in the database, or it can also be used as a way for migration from one data to another data. So all such use cases are there. So having said that, let me switch to my demo. Are you
Awesome.
able to
And
see
can
me
you do
speak?
me a favor? Can you just get slightly closer to your microphone? It could be me, but I was having a little bit of trouble hearing you there. You were a bit quiet.
Okay. Is it better now?
Yeah, just keep leaning
Yes.
in. Don't sit back.
Okay. Okay.
Thank you.
Okay. Thank you. So here, the whatever I showed in the picture, the same cluster that I'm showing here. So we have one coordinator node that is located in 9700, and there are two worker nodes that is in 9701 and 9702. Right, these two worker nodes are there. Let me create a sensor table here, and we would look at uh, how these changes are passed to the Kafka client. Okay. Let me create a table, and then let's distribute it. Okay, so now we have distributed this table, and we can see the shards being present in the two worker nodes. Normally, the shards are not shown, but just for the demo purpose, I have enabled it so that we can see that the data is going to two worker nodes. Now, in order for us, a Kafka cluster to be able to get the data from here, we need to create a publication. So, I'm creating a publication. If this publication is a concept, it tells which particular table in a database. The database can have multiple tables, but which particular table that the client is interested in. Right? So, we create a particular publication saying that this is the uh, table that the client may be interested in. So we give a particular name for it. Now let us go into the Kafka side. So I am just going to start a Kafka cluster now. As we know, the Kafka cluster requires a zookeeper. So let us give it a second for the zookeeper server to start. So we are running the zookeeper here, and then I will run the actual Kafka broker. So there are a lot of messages here, but don't worry about that. It is just the Kafka server is starting up. Now, uh, as we see in the image, so the Kafka server requires to connect to all the worker nodes to get the change, and this is done through a particular connector called Devisium, and that is what we are going to start. And we will start at connector 1 for the worker node 1 and connector 2 for worker node 2. But before we go there, let me show how this is configured. If we look at, there are two connectors. One will connect into worker node 1 and the other connector to worker node 1. As is so, this 9701 is the worker node 1. Uh, this is worker node 1 and 9702 is worker node 2. So that is what I am configuring here. And the another important thing that we need to mention here is we need to create a replication slot, and that is specified here. It will automatically get created. And as I told, this particular publication name is important. So whatever publication name that got created, that same should be mentioned here, so that the Devisium connector will connect to the appropriate slot, and then this connects to the publication will create basically look for all the changes in the sensor table. So the public is the schema and sensor is the table name. And similarly, we do the same thing for worker 2 also. Just we are changing that it is to the port number 9702, and this is the the top level Kafka topic name that we are giving. Okay. So, and there is a one small change, right? There is we will see that when we are running this client division, we are giving standalone properties. While that is being set, for the next standalone property, this port number needs to be changed. So default it is 8083, And since each one is connecting to a different port, this port number has to be changed.
Could you lean in a bit more towards your microphone again?
Okay. Is it better?
Yes.
Oh my
much
goodness,
better.
yes.
Okay, sorry. Okay, so I have showed the configuration. Let me run the Debian character 1. And let me run the connector 2. Okay, both are connected now. Now we run the application that actually connects and listens to this Kafka event. So this, if you look at this, I am specifying that this 9092 is the broker that we run, and the topic is the DB test server public.sensors. That is what we specified here in the connector property. This is DB test server, and this public.sensor is what we are. This particular application is looking. Now let me go back and let us make some changes. Let us insert some data, and I'm just inserting one row so that we can see what is the change that is happening. So I am inserting a particular row, and then with multiple data here. So I inserted the data, and you can see that this application immediately got that event. So here you can see the before there was no data, and after is this whatever we inserted. We got the measure ID, and we got the data that we inserted. The application gets it, and you can also see that what is the type of event is specified. It is in the schema public and sensors, and then you say what is the DB that it happened and what is the operation. Right. So all that we can get.
So
And
what kind of operations are there?
there are insert, updates, and deletes. So those events are, we can also get
and so the C is create or something.
right. Yeah.
Okay.
Yes. Yeah. So and now let me try to update the same row. So all I'm doing here is by default this particular column has a default data, and we are updating the data. That one particular column to new data too, right? So if we look at here, what we see is that this is the update event view, and all the other details are there, and then we see the data that it got updated, but we didn't see what was the data before, right? That is because we don't have set the replica identity. So this is required to uh, for the application to get the previous data also. So it can know which data it was there before and what data it got changed, right? So now I set it to the identity pool. Let me run the same command again with the new data. So I give new data as 3, and then now if we look at, so we get both the before and after, right? So we get the before new data 2 was there, and now we have a new data 3, right? So so we covered insert and update. Let us do a delete, right? So I am just going to delete the row that I just did. So I delete the row. So now I go and see, you can see that the before event is there. This is the delete event, and then you have a before and after is none, right? So this way, a application that is listening in this Kafka topic can know any insert, update, and delete is happening. And there is one more important thing is that, see, the actual event, right? Actual data would have gone into one of these shards here. The insert would go to a particular shard in the distributed table, but that gets translated to the distributed tables name here, right? So when the application sees it, it doesn't see it as a change to a particular shard, but rather as a change to a particular distributed table, right? So this is the one of the things that we have done for this release. So this is done on top of the logical replication. We have a decoder that would convert this from the shard names to the distributed table name. And also another thing is this, when you have the distributed table, sometimes you may need to have to split the table, or you may have to move the shard from one table to another table, or you run a rebalance operation. While doing that, by normally the logical replication doesn't differentiate this kind of event, so you may get a duplicated event. But with this release, we have worked on that, and then any shard management operation, shard move, will not result in a duplicate operation. Just to show us an example, so I am going to move one particular shard here, that is 102.538 into 102.538. As you can see, it is in the worker 2, that is in 9702. Let me move this to 9701, right? So right now we don't have that. So let me run this to move. So this shard has been moved there. So we can see this whatever we moved, 538 has come here, and it will move from here. Right? So the shard got moved, but as you can see, there is no event, right? So there will be multiple rows in that table. While moving that, they don't emit any events to the Kafka. So the application can work from the logical view of the table instead of a particular, any operation that is happening in the cluster will not affect the view of the application, which is listening to these changes. So I'm just showing Kafka as one example, but the same mechanism should work for any event streaming like a Pulsar or any other framework that is there, which listens to these events, that works on top of logical replication. This should work. There is also another use case where you can use this to replicate a distributed table to a particular Postgres table. But we don't have time to cover that, but all the instructions are there in the updates page. You can have a look at it. And so this can also be used to replicate a distributed table from a Citus cluster to a Postgres server. If there is a need for that, this can also be used for. So yeah, that's all I have.
Thank you, Rajesh.
Thank you.
All right, we have questions. Yelta.
So you said like during a shard move, you wouldn't get these duplicate things. How does that work? How do we know that it's a shard move?
Yeah, so we have a replication origin field so all this thing works with the write ahead log. So all the data changes happening is written to the write ahead log, and that is what we are decoding and then sending it to the client. So at that point, whenever there is a shard movement or shard split, so we insert this replication origin field with a special value, and by seeing that, the CDC decoder will know that this is happening because as part of a shard movement management operation, split, move, or rebalance or anything. So it won't publish those things. So that is how we avoid publishing that.
Okay, so when we do the move, before we actually do that, we say like ignore all these things for
right, exactly.
Okay.
And I guess my question was about what use case, what developers would want to use the feature that you just demoed? Like, when is it most commonly used?
It is most commonly used as a it could be from one microservice to another microservice, and this microservice 1 is writing to a particular table, and microservice 2 when that particular event happens, it may want to take an action, right? So it could be one of this use case. Other use case could be the auditing. For example, you have an employee table, and some sensitive information like payroll is there, and for whatever reason that you don't want something to be changed without any authorization or any particular approval, so we can have a component that is completely outside the database, which is listening to this and then based on it, it can take action. So if there is any changes happening in the database, then this component will automatically get known without uh, putting more load into the database, because this is happening outside the transactions and with the valve decoding. So this is an easier way to stream the events that is happening within the database to outside that.
Got it.
Okay.
All right. Well, thank you very much, Rajesh, for joining us today
you.
and for giving us this demo. Appreciate it.
Thank you. Thank you.
All right, Yalta, 11.3 release party. I think we're all wrapped up. If you want to know more, you can go look at the overview of the blog post that I showed earlier. You can go look at the website and go to the updates tab in the top navigation and take a look at the 11.3 updates page. What else? Any other pointers?
I think those are the. I mean, Ozan wrote a blog post recently, and there will be some more blog posts coming up soon. So be sure to keep an eye on the blog if you want to read some more details about some of these topics.
And then you can always ask questions on the site of Slack. So feel free to join us there and drop questions in. We've got engineers in lots of different time zones and geographies. So the conversations tend to be pretty asynchronous, but still useful to get answers to your questions. So I think it's a wrap. Thank you very much, everybody, for joining us today.
Thank
Yalta?
you.
Awesome. Great to see you.
Have a nice day, evening, whatever, wherever you are.
All right. Ciao. Bye.
Bye.